So because we have that negative there, well, I guess really anytime we don't really know what we're doing, we're going to find our reference angle. If it's a positive answer, remember that your reference angle is the same angle as in quadrant 1. But because that's a negative, it's really important that you find your reference angle. To find your reference angle, you drop the negative. So this is back to grade 11. Yeah. Okay, so we're going to do, in our calculators, first of all, we got to figure out what units we need to be in our calculators. Yeah. Because you're solving for the angle. So the reference angle, you're always trying to find the acute angle that's measured with the x-axis. So you have to drop the negative. Because you're trying to find, just like in quadrant 4, if I'm looking for this angle right here, if I'm looking for 11 pi over 6, what's my reference angle? It's this cute little tiny angle here, right? So it's 30 degrees. What's the rule for quadrant 4? No, has to be 30. What's the rule for quadrant 4? Your reference angle, right? So 2 pi take away your reference angle. So your reference angles always have to be positive because we're putting them into the rules. Okay, so is my calculator in radians or degrees? How come? Close. My calculator has to be in radians because what's my restriction in? My restriction's in radians. Okay? So your restriction is going to tell you what units you need to be in your calculator. So I'm going to go here. I'm going to use my handy dandy calculator. I'm going to go second function sine, put in a positive 8.79. Okay, so this is in radians. So my reference angle is in, my reference angle is 1.0738. Sorry, I'm just going to round it. Technically, I should use all of them, but we're going to do baby steps. Okay, so this is getting bigger, right? Full rotation's not a problem. Full rotation's not a problem. You're going to use your rules from your quadrants. So in quadrant 3, yep. In quadrant 3, they're from grade 11. They haven't changed. In quadrant 3, pi plus theta reference. Mm-hmm. Oh no, we still have like 4.6 to do.
Are we gonna have the pop quiz for our quiz?
Do you think you need the pop quiz for your quiz? Okay, we're finding reference angles for. I don't even know what a reference angle is. That's scary. I taught you. I added pi plus 1.0738. Can we write down the quadrant rules again, please? We have them. But I don't even know where they are. They're in this book. No. Because they're from grade 11. Why is that not fair? Oh, 4.1 reference angles. There was a whole lesson on it. Oh, it's a separate page. We did them, they were a separate page. Okay, what's the rule for quadrant 4?
Why'd you add pi? Why'd you add, oh, because there's two answers?
Yep.
So you add pi.
Because this is the rule for quadrant 3. This is the rule for quadrant 4. The negative told us we were in quadrant 3 and 4. That's why I'm using these rules.
Okay, so what are we finding right now? Like, what is this calculating?
We're doing what we just did, but we're finding the exact value.
But what do you think that means? There you go. You don't need to put the subscript of 4. 4s don't mean like to the exponent of 4 or anything like that. It's just a way to help me keep myself organized.
Are we done?
No, we haven't done our negative rotation yet.
I want to move on to lesson 6.
Pardon?
I want to move on to lesson 6 now. I want to do trig equations.
You don't want to do or you do want to do?
I do trig equations. I'm part of this.
It's going to be addition to this. Like it's going to be add on to this. So if you can't do this, trig equation, like this has to come before trig equations. Okay. All right, ladies and gentlemen. Okay. Instead of saying, I don't get it, I don't understand it, I don't know where we are, take a moment, ground yourself, think about a unit circle. Where are you? Like, where are you on the unit circle with those? They're numbers. We don't normally deal in just numbers on the unit circle. But where are your two answers? Quadrant 3 and 4. So let's say we have one here and we have one there. Does it really matter? Okay, so let's talk about our negative rotation. So we did our two positive ones. That's done. Like our two in the positive direction. Now we have a negative rotation. Negative half rotation. So we are from here to here. So you guys would agree that theta at this point is 4.2154 and theta here is 5.2094. They're not exact values. But we do know they're in quadrant 3 and we know that they're in quadrant 4, right? We know that those are where the answers are.
So when you say reference angle,
Mm-hmm.
are those positive? Are those positive answers?
That's not what a reference angle is. The reference angle is this in here.
So we're finding the point that the reference angle came from.
And this reference angle in here is 1.703. So that angle, and what we're measuring now is from here to here, right? And then we're measuring from here to there. So that 5.3 is the pink line measurement. That 4.14 is the yellow line measurement. Okay, does that make sense to everybody? Sure. All right. So now, what do I need to find? Am I going to hit both of them in my restriction? Yeah. So I'm going to have two answers in the positive, and I'm going to have two answers in the negative.
Can't you just take away a full rotation?
So you're going to find this is where your coterminal angles are going to come from. You can't math this one out using this because it's not an exact value. So you got to use the negative coterminal angles. So what's a negative coterminal angle? So I need a negative coterminal angle for this. So what am I going to do? I'm going to subtract 2 pi from it. So I'm going to have 5.2094 minus a full rotation. Only benefit to this is you don't have to deal with fractions.
Can we just type that in?
Yep. I can on my calculator. I don't know if you can on yours.
Well, tell me what I'm supposed to get.
But that makes sense, right? In quadrant 4, that makes sense that that's what it should be. Okay. So this one's gonna be, if I want to find the reference angle, the negative reference angle for here, same thing, I'm gonna minus 2 pi from it.
Are we done now?
Okay, I just want to write those answers on my sheet. So can you guys remember how to do that? Yes, yes is the correct answer. With a little bit of practice, I think you can. Okay. Do you want to do this one as, I think we need to practice on the calculator. I think we need to practice on the calculator. Ooh, okay, the negative tells us what? The negative tells us we're in quadrants 2 and 4. Okay, so now that I have that, what's my next step? So this is step 1. Step 2, we're going to do our reference angle. Okay, and the way we deal with our reference angle is, what do? Drop the negative. So this is where you use your second function button in your calculator. And what units am I in my calculator? I'm still in radians because all of our restrictions are that radian one.
Why do you drop the negative?
Because your reference angle is always going to be an acute angle. It's always going to be small. Okay. You like the calculator one? Okay, all right. 1 over 6 times 5? Times pi.
My calculator's weird, brand new and stuff. But like.
Oh no, okay. We're in degrees. That's the first problem. No, you're in radians. Okay.
Like, look, just even try like 53 times 3, or 53 divided by 3. Like, it won't divide anything that,
We just gotta change the mode, I think.
yeah, like, my answer will literally just come out to 53 divided by 3. Like, it won't give me a decimal.
Okay. Sure, see, how do we fix this? It's, let's go 8. 1. 53 divided by 3. How do I get that to a decimal? Oh, right here. Right there. Yeah, I have.
I think it's just that you have to click it once.
Once? Okay. So we try that again? No. Looks like it. Or maybe there's a way we can set it, but I don't, yeah, for sure. Okay, did you guys go on and solve for the other? Perfect. What quadrant, what's the rule for quadrant 2?
Pi minus theta. So when you say rule, it's like the equation.
Yeah, yeah, sorry. And you guys are using the pi button in your calculator? Okay. Ooh. And what's the rule for quadrant 4?
I got my positive.
Now again, this one we're just doing the 2 because we have a full rotation, but really double check on your restriction because each question you're going to get is going to have a different restriction on it. Did you? Okay. So let's talk about where we are for a second. Can I move that? Can I slide it up a little? So where are my answers? Where are my answers? They're in 4 somewhere, and they are in 2 somewhere. Okay? So my restriction on the back end of this is just a negative pi. So how many answers am I going to have on my negative rotation? Just the 1. So what's the angle measurement here? This one's my 5.7596. So this is the only one I'm going to find a negative coterminal for. Why? Because it's not in that restriction, right? So you got to keep checking where you are and where your restrictions go to. So we're going to take 5.7596. We're going to do negative 2 pi. And hopefully that's going to give us our reference angle. But it should give us a negative one of those, right? So my answers are this one, and that one. Is my reference angle an answer? No. No, it is not. Okay, I'm going to hit freeze on the screen. You guys are going to do this last one on your own. Okay? Because then you're going to what? Yep, because this is not an exact point on the unit circle. Nowhere is sine 2 over root 3. Lots of places sine's root 3 over 2. Right?
So if it's already a positive, you just leave it.
Mm-hmm.
Can we just put 2 over root 3 in the calculator for the reference angle?
Yeah. Well, in my calculator, I can.
Did you get a number?
I did. Hang on, I'm not even there. I'm going to get a number, though. I promise you I'm going to get a number. Ah, I know why. Did you guys get an error? Perfect. You should have gotten an error. Okay. So if you guys actually do 2 divided by root 3, if you just do 2 divided by root 3, you should get 1.1547 something, something, something. Okay? Sine and cosine, are they ever greater than 1? Never. When you were in grade 10, they were never greater than 1. When you were in grade 11, they were never greater than 1. And grade 12, they're not greater than 1. What's the max value sine can be? You guys know that sine is the y value. What's the highest point on this circle? So can I be above 1? No. So this is no solution. No solution 1? Can tan be greater than 1? Yes. Sine and cos can't, but tan can. Okay, I know what your answer is going to be. I just need to think about it. I think today we're going to stop here. I'm going to move 4.6 to tomorrow.
But then we have to do the quiz right after that?
Okay, we're going to do 4.6 tomorrow, and we're going to assess after that. We are going to assess after that. Okay, no, we are going to assess after tomorrow. Okay? We're going